We have a three-dimensional diagram, and we are required to extract three triangles in two-dimensional representation. We are required to extract each of the triangles from the 3D diagram, which is what we always do graphically or mentally while finding a side or angle in a 3D diagram. We always do this. However, it is on this occasion that we are required to do it deliberately. Generally, we just make use of a 3D diagram without much consideration. However, on this occasion, we are required to do it as a part of an assessment. We may work with each triangle individually, but it will be more efficient if we consider the diagram as a whole. The first consideration is that the tower is vertical. This makes it perpendicular to every horizontal line or every line on the ground. This causes TF to be perpendicular to both SF and SR. This tower is vertical. Because it is vertical, it is therefore perpendicular to every line that is on horizontal ground. RF, or we may say FR, is on horizontal ground and FS is on horizontal ground. The tower is therefore perpendicular to both of those lines, and we will show that it is perpendicular to FR and it is perpendicular to FS. R is east of F and S is south of F. Lines going east and south are perpendicular to each other. Therefore, we have another right angle, and that is located at the vertex SFR. SFR, well, it is the same vertex that all of them are located. We have another right angle located at that vertex because R is east of F and S is south of F. We will have a right angle right there. The angle of elevation of the top of the tower T from R is 27 degrees. The angle of elevation is taken from R. It is therefore located at R. There's an angle of elevation to be given consideration to in the diagram. It is the angle of elevation of the top of the tower T taken from the point R. Therefore, that angle is located at R. Each line is perpendicular to the other two. They are a set of mutually perpendicular lines. Extracting each of the triangles is not difficult because they are all right-angled triangles. All of the triangles are right-angled triangles. It is therefore not difficult to extract the triangles. As a matter of fact, all of those lines are mutually perpendicular, meaning that each one is perpendicular to the other two. All of the triangles that we are required to extract are right-angled triangles. All of the triangles are right-angled, but in this 3D diagram, only RFT looks right-angled. We may just reproduce it as it is. In the 3D diagram, only that triangle appears to be right-angled, so we just take advantage and go at it and make that be our first. TFS is also right-angled with the right angle at F. TFS is right-angled and the right angle is located at F. And that is reproduced in such a way that the right angle is located at F. And we have our right angle triangle, TFS. SFR is also right angled with the right angle at F. That one, FSR, is also right angled and the right angle is located at F. There's no difficulty. Also, the diagram is not drawn to scale. We are not required to reproduce the triangles drawn to scale. Therefore, the most important thing in this diagram is the position of the right angle, and as long as we have that correctly done, then we are sure that the triangles are correct. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.